Now this video is going to be on bearings. Now bearings is another angle topic, but bearings are special kinds of angles used to communicate position to people. And in order to do that accurately, they need to follow three rules. Now the first of these rules is that all bearings are always 3 digits long. Okay, so that's why sometimes you might see bearings written with a couple of zeros in front. Secondly, they are always measured from north. Now, north on maps and pieces of paper is always up the piece of paper. And thirdly, they are always measured clockwise. So all of these three rules help to make calculating these angles consistent from person to person. So when you communicate 30 degrees as a bearing to somebody, they can draw on their map 30 degrees and it'll be exactly the same as the 30 degrees that you drew on. Okay, so let's look at some examples. So example 1 is measuring bearings. Okay, so first off, when we start this question, we need to identify where the bearing is measured from. And in the question, it's saying that it's being measured from A. Okay, so the next thing we're going to do is draw our north line in. Okay, so the north line is going to be situated on A and it's going to go up our paper. Okay, so after you've drawn your north line in, you may want to put an N on it just to indicate that it's your north line. And just make sure that you're drawing this with a ruler. Okay, so the next thing we're going to do is we're actually going to join the points A and B together with a straight line. Again, make sure that you're doing this with a ruler. So after we've got our north line in and we've connected A and B with a straight line, we're going to have to get our protractor out. Now then, if you're not sure on how to use a protractor, then I suggest you look at the basic angles video where I go through using a protractor. Now we have to measure our bearing from our north line clockwise. So usually you'll see angles drawn with an arrow. This is to indicate the way they are measured from. So we're going to take our protractor, we're going to measure this angle here. So first off, I'm going to put my origin on my point A, and I need to turn my protractor so that my 0 line is sitting on the north line there. Okay, now I'm just going to check which scale has the 0 on, which is the outside scale. So using the outside scale, I can see that B is sitting at 54 degrees. So I have my angle, but is it a bearing? Okay, so I need to just check it against these three rules. So the first rule says that it needs to be 3 digits long. Now my angle here is not 3 digits long, so in order to do that, I can easily rectify this by putting a 0 in front. Okay, so secondly, it's always measured from north. Yes, I measured from north. And thirdly, it's measured clockwise. And again, I've measured it clockwise. So this here is my bearing of B from A. Okay, doing the second question, I'm going to start it off exactly the same way I've done before. I'm going to draw a north line from A and join A and B with a straight line. Now that I've done that, I'm going to get my protractor out. And again, on my diagram, I'm just going to indicate the angle I'm going to measure. And in this case, measuring from the north line and going clockwise, it's this big reflex angle here. So I'll just indicate that by drawing an arrow. Now, if you remember measuring reflex angles, it was a lot easier to measure the complementary angle inside. So first off, I'm going to measure this angle in here. After I've got that angle, my strategy is then to take it away from 360, as that is a full turn, and I'll get my reflex angle. Okay, so firstly, I'm going to put the origin of my protractor on the point A. Now I'm going to turn the protractor so that it is sitting on the north line. So using the inside scale, as my 0 is sitting on the inside scale, I can see that the green angle, the complementary angle, is at 116 degrees. Okay, so knowing this is 116 degrees, all I need to do now is have a 360, take away 116, gonna have to borrow, and I've got my bearing here of 244 degrees. So again, I'm just going to check it against the three rules. So first off, it needs to be 3 digits long. It is. Always measured from the north, which I have done. And it's measured clockwise, which I have done as well. So that is my bearing. So another question they could ask you to do with bearings is find the position of something given some information on that thing which involves bearings. So in this example, I've got a diagram which shows the position of two rocks A and B. The bearing of a ship S from rock A is 95 degrees. The bearing of ship S from rock B is 245 degrees. And I'm asked to mark the position of the ship on the diagram. Okay, so for this question, our strategy is going to be to draw these two angles on, one from A and one from B. These are going to be two lines that will meet at some point, okay? They will intersect. Now, that point that they intersect at will be the position of the ship S. So I'm going to start off by drawing in my north lines like I did when I was measuring. Okay, so the next thing I'm going to do is mark on my two angles. So I'm going to start with angle A, so I need a protractor. And I'm going to put my protractor's origin at A, and I'm going to turn the protractor around so that the 0 line is facing north. So using the outside scale, I need to mark on an angle of 95 degrees, which is roughly there. So removing my protractor, so joining this point up with A, I get my bearing of 95 degrees. So I'll just write that in, again putting an arrow in there to show that I've measured it clockwise, and that is 095, 95 degrees. Okay, so now I'm going to do exactly the same thing, only at B. Now, if you notice, B's angle is a reflex angle. So the strategy for drawing a reflex angle is to find its complementary angle by taking away from 360. And then if I measure that on anti-clockwise, then I should also get this 245 degrees clockwise. So I'll just demonstrate what I mean by that. So first off, going to take this away from 360. So borrowing, I get 115 degrees. Getting out my protractor, I'm now going to measure 115 degrees anti-clockwise. So I need to put the origin at B. There we go. I'm going to rotate my protractor around, this time anti-clockwise, so that 0 is sitting on my north line. And I'm going to mark on using the inside scale this time, because that's where my 0 is. I'm going to mark on 115 degrees, which is roughly about there. Removing my protractor and joining this point up with my point B, I've made my angle of 115 degrees, but this time anti-clockwise. If you remember, bearings are measured clockwise, and we should have a bearing of 245 degrees. So after drawing those two lines on, you can see that we were successful. These two lines cross at this point, so I'm just going to mark it with a cross. Okay, and this is where the ship is. So my question says to mark it with a cross, label it S, so that's what I'm going to do. Now in bearings questions, because it's about maps and mapping, they also like to include questions about scales. So I'm just going to go over a question in which they are incorporating bearings and scales as well. So here we've got a scale diagram where 1 centimeter equals 2 kilometers. Okay, so we have our map distance, which is measured in centimeters, which we need to multiply by 2. And that will give us our real distance measured in kilometers. And again, if we want to go back to our map distance, we need to divide by 2. Okay, so with that in our heads, we're now going to work out how far away rock A is from rock B. So getting my ruler out, I'm going to quickly put 0 on at A. Remember, you could just measure it from B as well. I'm going to tilt my ruler up so that it is level with B. And you can see here that the distance from A to B is 11 centimeters. So in real life, I need to times this by 2, which is 22, change the centimeters to kilometers, and I get 22 kilometers. Okay, so the second part to the question is very similar to what I did in example 2, only this time, instead of being given 2 bearings, I've given a bearing and a distance. So the question is saying that another ship T is on a bearing of 130 degrees from rock B, and it is 12 kilometers from rock B. So I'm going to start off by drawing a bearing of 130 degrees from rock B. So I start this off by drawing in my north line. So after I've drawn my north line in, I need to get my protractor out. And now measuring clockwise, I need to measure an angle of 130 degrees. So my origin's at B, turning it round so that 0 is on the north line, and now I need to measure 130 degrees on the outside scale because that's where the 0 is, and that is down there. Getting rid of my protractor and joining this point up with my point B with a straight line, I've put in my bearing of 130 degrees. Now my ship T is somewhere on this line. Now what I need to do is I need to work out what 12 kilometers is on my map. Now if you remember, I've got this little formula up here. If I've got my real distance in kilometers, I need to divide it by 2 and I'll get the distance in centimeters on my map, which is 6 centimeters. So all I need to do now is get my ruler and measure from B 6 centimeters. So putting my 0 on at B, tilting my ruler down so it's parallel with my line. Need to measure 6 centimeters, which is there. Getting rid of my ruler, marking this point with a cross and labeling that it is 6 centimeters along the line, and also answering the question by labeling it T. So this last example is again a classic bearings question that they could ask you on your GCSE paper. Now this one's a little bit different from the ones we've done before because it doesn't actually involve using a protractor and ruler, although you can answer it using protractors and rulers, but there is a quicker way just using our knowledge of angles. So the question reads, town W is on a bearing of 140 degrees from town N, and now I want to work out the bearing of town N from town W. Okay, so I'm going to start this off by drawing a diagram. Now, firstly, I've got town W on a bearing of 140 degrees from town N. So town N is going to sit roughly up here, and town W is going to sit roughly down here. Okay, so note that these positions don't need to be entirely accurate. You can do it accurately if you want to, but like I said, it's quicker to do it this way. So we're going to start off by drawing in our north lines. And now I'm going to connect town N to town W with a straight line. Okay, so the question reads that town W is on a bearing of 140 degrees from town N. So the bearing is measured from N. So remember, it's measured from north and clockwise, and that is 140 degrees. Now the question's asking for a bearing of town N from town W. So again, I'm going to mark this on my diagram. Remember, measuring from north clockwise. So I'm trying to find this angle here, X. Now hopefully you've noticed that these north lines are actual parallel lines. So we can use all of the rules about parallel lines here in this question. Now hopefully you've also noticed that these two angles, 140 and this angle here, are interior angles. And interior angles add up to 180. So I can find this angle here, which I'm just going to call y out, by doing 180 take away 140, which gives me 40. So knowing that y is 40, I can easily calculate what x is, because I know that these two angles add up to 360. So all I do is 360, take away 40, and I get the bearing 320 degrees. So this bearing here, x, is 320 degrees. Okay, so hopefully that's helped you with your bearings questions. Again, just practice, practice, practice. Do as many exam questions on this as possible. Make sure you clue yourself up on a protractor. Make sure you're equipped with a protractor and a ruler. And always use a pencil when drawing diagrams. Okay, good luck.